In this video, we will discuss about the primary and secondary standards substances and their solutions. So we will discuss about the primary and secondary standard substances and how we will make their solutions. So we will first discuss about the primary standard substances. Primary standard substances. In preparing standard solutions for volumetric analysis, different reagents or chemicals are used. The reagents which are available in pure conditions, these chemicals are reagents which are used in pure conditions, and they are unaffected by atmosphere, unaffected by atmospheric atmospheric oxygen, moisture, CO2, moisture, CO2, and stable during storage, stable during storage in their original state. So, in preparing standard solutions for volumetric analysis, different reagents and chemicals are available. Used. Those reagents which are available in pure conditions and they are unaffected by atmospheric oxygen, moisture, or carbon dioxide, and are stable during storage in the original conditions state. These are called primary standard substances. Standard solutions of them. Standard solutions of primary substances. Primary standard substances can be prepared by directly weighing the necessary amount of primary substance and then dissolving in the required amount of water. The solution prepared from them are called primary standard solutions. For example, potassium dichromate. This is a primary standard. Primary. This is a primary standard. It is oxalic acid, dihydrate. This formula COH twice 2:2 O. Anhydrous sodium carbonate. Anhydrous. So, and potassium iodate. Potassium iodate. So, these are primary substances. So, standard solutions are the primary standard substances can be prepared by directly weighing the necessary amount of primary substances and then dissolving in the required amount of water. The solution prepared from them are called primary standard solutions, such as potassium dichromate. If we form a solution of potassium dichromate, it will not need to be standardized because this is the solution of a primary standard substance. Similarly, oxalic acid dihydrate and sodium carbonate anhydrous. This is also called primary, primary standard substance and solution of the sodium carbonate which has been prepared will be called primary standard solutions. So we can say that potassium dihromate, potassium iodate, sodium carbonate, anhydrous, as well as oxalic acid, dihydrate, oxalic acid, dihydrate. So these are all are called primary standard substances, and solutions of them are called primary standard solutions. Primary standard solution. Now let's come towards secondary standard substances. And their solutions. So what are secondary standard substances? Uh, reagents, chemicals, reagents, chemicals, which don't possesses, don't possess the qualities which was discussed are called secondary standard substances. And the solution formed from secondary standard substances are called secondary standard solutions. Secondary standard solutions. So first we will know about which are secondary standard substances. For example, secondary standard substances. For example, KMNO4, potassium permanganate, H2SO4, sulfuric acid, HCl, hydrochloric acid, and NOH are called secondary standard substances. And solutions made from these are called secondary standard solution. Secondary standard solutions. These solutions formed from these substances such as potassium permanganate, H2SO4, HCl, and NOH are to be standardized before use, though titrations, which are suitable solutions for strength, is exactly known. So we can say that we will titrate secondary standard substances against primary standard substances, because the strength of this are unknown, and we will standardize by titration of the secondary standard substances against primary standard substances whose concentration is known. Now let's come towards how to prepare DC normal. DC normal 10 by 10 solutions of sulfuric acid H2SO4, HCl and OH. We know in case of sulfuric acid, if we want to prepare these normal solutions, we know that in case of sulfuric acid, its formula weight is 98 gram per mole, while its covalent weight is 98 divided by 2, 49 gram per covalent. We divide this by 2 because there are two hydrogen, the plasma hydrogen atoms in sulfuric acid. So this is the formula weight and this is the covalent weight. This is the covalent weight of sulfuric acid. So we know that for one normal solution of sulfuric acid, we need 49 gram. 49 gram of sulfuric acid. And for 14 9 by 10, as we know, this is the normality and the equivalent weight, so n by 20, 10 by 10. So n will be this 49, and we need n by 10. Also, we divide the 49 by 10, by this 10, and we will get 4.9 gram. So 4. You can say 40 covalent weight of H2SO4, 49 gram covalent, and n by 10 solution of it will be 49 by 10, and that will be equal to 4.9 gram of H2SO4, 4.9 gram of H2SO4 of pure sulfuric acids are to be dissolved in DMW and make the volume of 1000. This, for example, this is a flask, and we have taken 49 gram of pure H2SO4 here, and we will add DMW. This is a flask of 1000 ml, and we will add this mark. We will add water to this mark. This is the, and we will take 4.9 gram. So this will be the n by 10 solution of sulfuric acid. But here the question is that we cannot take 4.9 in gram directly, because it is a highly hygroscopic in nature, because H2SO4 is hygroscopic in nature. Hygroscopic in nature. Also, it is close to amphibian liquid in a precision chemical balance. So you noted that sulfuric acid is also a corrosive and fuming liquid. Sulfuric acid is corrosive and fuming liquid, and it is not to be well to be taken directly in raw. So we know that sulfuric acid is available from 95 to 98%. So we can measure, we can just take its volume in cylinder instead of taking it in raw. How we will convert it? We need this 4.9 gram. As we cannot take this 4.9 gram directly, so we will convert it into ml. So the question is that how will we convert this 4.9 gram into its equivalent of milliliter or ml? So for this purpose, we are necessary to know about the density of sulfuric acid. So for one normal H2SO4, we know that 49 gram is needed per 1000 ml. 1000. So we will convert 4.9 gram into its equivalent ml. You can say gram into ml. So for this purpose, we can say that its percentage purity of sulfuric acid is 98%, and its density is equal to 1.86 gram per ml. So therefore, when we know its density, we can easily convert 4.9 gram into its equivalent ml. For this purpose, we can take 4.9 gram into its density 1.86 gram per ml. Gram are cancelled. Its percentage is 98%. So we'll write 100 divided by 98. So percent. So we have only this unit remaining because these are cancelled. They are cancelled. We have converted the percent into we can write 100 divided by 98. So gram and grams are cancelled each other, so we will get only ml unit. And the result will be 2.7 ml. So instead of taking 4.9 gram of sulfuric acid, we will take 2.7 ml because we can take easily 2.5 ml of sulfuric acid in a small measuring cylinder such as this, like this. Can have a measuring cylinder like this, and we can fill the pure H2SO4 up to about 2.7 ml, which will be equal to 4.9 gram. So we can take this cylinder up to this mark. Up to this is example say this mark. So this is a 2.7 ml of sulfuric acid taken, and we can and this will be added on. This sulfuric acid will be added into 1000 ml of flask. This is, for example, a flask of 1000 ml. So we have here water present already here, and we can put it this 2.7 ml of sulfuric acid into this flask, and then make the volume of the mark of 1000 ml. So we have prepared a solution of sulfuric acid. What this solution will be n by 10. N by 10 solution of sulfuric acid will be 2.7 ml of pure sulfuric acid into this, and first into this containing water, just half filled, and then make the volume of 1000 ml. So this will be the n by 10 solution of sulfuric acid. Now consider we have taken 20 ml 20 ml from this solution, 20 ml from this solution of sulfuric acid of N by 10, and we can standardize this with primary standard sodium carbonate. So how can we do it? Let's take 20 ml of prepared solution, standardize with sodium carbonate, which is of concentration 0.12 normal Na2CO3. So, for example, we have here taken 20 ml of prepared N by 10 solution of H2SO4, and we will titrate with against sodium carbonate. So this will be added from here, distributed. So let's consider 21 ml of sodium carbonate has been used in order to complete the reaction or the set get their point. So how will calculate the concentration of sulfuric acid we have prepared? So applying the formula C1 1 is equal to C2 V2. So here we know that this is the concentration of unknown, for example, unknown concentration, but we know the volume, which is of sulfuric acid, which has been taken, which is 20 ml. The concentration of this sodium carbonate, we know its concentration is point C2 0.12 normal, while its volume used, this one, V2 will be equal to 21 ml. So we can determine this C1, so C1 is unknown. Simply, simply just to do that C1, which is required, C2 into V2 divided by this one, V1. So C2 is 0.12 sodium carbonate, 0.12 molar, 0.12 molar, 0.12 molar into volume, which is taken is, which is used is 21 ml divided by 20 ml of sulfuric acid, which is taken. So on this sum, we will get 0.126 normal solution of sulfuric acid, but as we know n by 10. So n by 10 for not of 10 n by 10, we'll just divide this by this way by 10. So this will be 0.126 n by 10, and this will be equal to 1.26 n by 10. Normality factor. What is normality factor? For example, the normality factor is just basically amount of substance taken by actually amount of substance taken by H1 being taken by H1 divided by exact amount required exact amount required. For example, for preparing N by 10 solution of sodium carbonate, we require 5.3 gram. 5.3 gram, for example, is required for N by 10 solutions preparation, and mistakenly we have taken 5.368 gram. So instead of taking 5.3 gram, we have taken 5.368 gram mistakenly. And how we will do? Because this 5.3 gram is required for 1000 ml. This will be for 1 liter, 1000 ml. If you mistakenly take this extra weight, 5.368 gram, then how we will adjust this? This is simply done by dividing 5.368 gram by 5.3 gram. Gram will be cancelled, and that will be factor will be 1.013. 1.013. So the strength of the solution is 1.013. So we can just multiply this by 1000, and from this ml, this we will get 1.013,000 into 1000 ml. 1000 will be cancelled, and we will get 1013 ml. So we will add extra water up to 1013 ml in order to adjust the solutions so that the validity is not disturbed. Therefore, dilute the N by 2 solution up to 1013 ml. By adding 13 ml extra water in W in order to prepare exact N by 10 solution of sodium carbonate. N by 10 solution of sodium carbonate.